This problem is from GATE 2021 Mechanical Engineering of Set 1. The question says the value of limit x tends to 0, 1 minus cos x divided by x square is. So in this problem we need to find the value of limit x tends to 0 for the function 1 minus cos x by x square, and the given options are 1 by 4, 1 by 3, 1 by 2 and 1. If we directly substitute the value of this limit x tends to 0, 1 minus cos x divided by x square, if we directly substitute the value, what we will get? 1 by cos 0 is 1 divided by 0 square, so that will be equal to 0 by 0. Now this is indeterminate form. So this type of limits can be solved using L'Hopital's rule. Now let's understand what L'Hopital rule says. It says suppose there is a function f of x, that is limit x tends to a, f of x equal to 0, and limit x tends to a, the function suppose g of x is equal to 0. Here f of x as well as g of x exist. Okay, so these two exist. Now according to L'Hopital's rule, some function h of x is equal to limit x tends to a, f of x by g of x. Now see, limit f of x, this is also 0 and g of x will be also 0. So this function will be 0 by 0 form, and it can be written as limit x tends to a, f dash of x divided by g dash of x. This will be equal to limit x tends to a, f dash of x, that means derivative of f with respect to x, and divided by derivative of g with respect to x. This will also be equal to limit x tends to a, f double dash of x, that means second derivative of f with respect to x, by g double dash of x. And this process will continue. This will keep going on unless we get a value such that h of x belongs to a real number. Unless we get h of x real number, we will keep differentiating the numerator and the denominator separately with respect to x. Now coming to our problem, we are given limit x tends to 0, 1 minus cos of x divided by x square. Now this is also a 0 by 0 form. What we will do, we will differentiate the numerator and the denominator separately. So we can write this as limit x tends to 0. Now if we differentiate the numerator, so we can write d upon dx of 1 minus cos x whole divided by d upon dx of x square using L'Hopital's rule. Now this can also be written as limit x tends to 0, and the differentiation of 1 will be 0 minus the differentiation of cos x is minus sin x, and whole divided by 2x. Now if we substitute x is equal to 0 here, we will again find that this is also a 0 by 0 form. So again we will apply the L'Hopital's rule. So what we can write here again, applying L'Hopital's rule again, what we can write, limit x tends to 0, d upon dx of sin x divided by d upon dx of 2x, and this you can write limit x tends to 0. Now the differentiation of sin x will be cos x, and differentiation of 2x is 2. Now here we don't have the 0 by 0 form, so now we can substitute the value of x is equal to 0. So we will get cos 0 by 2. Cos 0 is 1 and 2 will remain as it is. The value of limit x tends to 0, 1 minus cos x divided by x square will be equal to 1 by 2, and this is going to be our final answer. Now let's match with the given options. So we see here that option C matches our answer. So option C is the correct choice. If you wish to have more information on L'Hopital's rule, you can follow the lecture of Professor P.D. Srivatsava from IIT Kharagpur on the topic a basic course in real analysis. Hopefully I was able to clear your doubt. Have a great day. Thank you.